Hi Srinivas, can you hear me?
Yes, I can hear you. Hi, Farhan.
Cool. Thank you. How are you?
Good.
So I'm just waiting for everyone else to join. And
Yes. Yeah, I think I was early. I realized that.
great, thank you. I think we are right on time, but yeah, it might take a couple of minutes for everyone to join.
Right.
Hi everyone. Thank you for joining on time. It looks like we are going to have to wait for some time because people are still trickling in. So once we have the numbers, we will start in perhaps a couple of minutes. Okay, cool. So I see people are still joining, but we will start at 4:35 sharp. I don't want to keep anyone waiting.
Farhan, how many attendees do you have signed up?
We have 13 right now.
13. Okay.
Okay, I think we got to start, and the session is getting recorded. So in case someone is not able to attend live today's session because of some business needs, then they can always watch the recording. So I would like to welcome you all. once again, thank you for taking out time. I know it's in the middle of your working hours. I'll introduce myself in a little bit, but this is the kick-off session for the three course, uh, three module course on reinforcement learning that we are calling reinforcement learning in action. And the idea is to do sort of a walkthrough up on what the course is about, and what the takeaways are, and how much time commitment is needed from the learners, and what the class structure is going to look like, what will be the format of the class, all of those things. And of course, if you have any questions about anything related to the course, I believe we have circulated a flyer with the syllabus of the course linked inside, so everyone has a rough idea that uh, what the course is roughly going to look like at the top level. And I'm going to do a little bit of a deep dive. Uh, so let's get started. So before I do that, because we are a small cohort, what I would like to do is have a quick round of introduction from everyone, and we have this sort of fun introduction format that we are going to follow. I'll start with myself, but basically what we have to do is we have to uh, just say out our name, and then whatever we do, whether it's for fun or for profit, work or outside of work, whatever you like doing. And then there's a fun question, which is, what does AI stand for? What does AI mean to you? Not looking for genuine answers, not looking for what the abbreviation stands for, but just wrong answers only. So let me attempt it first. So my name is Farhan. uh, the you can see the pronunciation there in different languages. I tend to use the pronouns he and him, except when I'm writing C++. And what do I do? So I was a software engineer for some time, actually a long time, about 8 years. And then I grew interest in AI research, and I sort of switched career tracks. I was interested in training, so I switched careers, and I became an educator. And I'm still an AI researcher, in the sense that there are things I'm interested in. So I keep poking around, I keep experimenting, and I keep learning. So there are only two things that I like to do. One is learning for myself, and the other is helping other people learn. And I really derive a lot of enjoyment from that. Being able to help anyone pick up the most cutting edge skills. So that's sort of my motivation. uh, what you see here is a list of things that I do. Some of them I do for fun, some of them I do for profit. Sometimes there's overlap. So as a fun activity, I just want everyone to take a guess and see which ones we can get right. So on the left, you have things that I've been doing for the last 3 years or so. And on the right, you have to guess whether I do that for fun or I do that for a living. So I hope you can see a chat box at the bottom. And let's take the next minute or two to try to attempt this fun quiz. Shall we give it a try?
Sure.
Cool. So leave your answers in the chat box. I have the chat box open. I don't see any replies right now. But what do you think I do for fun and things I do? Yeah. So some people actually believe I do everything for fun, which is kind of sort of resonates with me. I even things I do at work, I do them for fun. Okay, that's very cool. So I'm going to reveal the answers. It's not a real quiz, but thank you for you know trying to guess. So things that I do at work. My job is such that I research how to deliver learning in an accelerated fashion. So whether that is the mode of delivery or other modes that can make you know any kind of learning engaging and fun and exciting. So that's something I do for a living. And because I am in the space of AI and machine learning and sort of autonomous vehicle research, so when I try to apply those techniques of accelerated learning is mostly in these domains. But I'm also interested in other subjects, and it's always to chat, great fun to chat with someone who's also interested in just thinking about how learning can be more fun, whether it's something you want to learn for apply at work or in general. So always up for it. uh, Outside of work, I try to take out some time and work on self-driving cars, not the real one, not the one which are made out of metal. I'm more interested in simulations, so I work on stuff inside simulators. And there's a lot of opportunities these days because there's a lot of realism, so you can do things in simulator, and which is very close to what you can do with a real car. I'm also interested in deep learning and deep reinforcement learning, so uh, I try to. Okay, am I audible? Is the volume okay now?
Yes, Farhan, you're audible.
Thank you.
Yeah, you're audible. But the volume could be a little louder. I mean, if you want
Sure,
to
sure, sure.
increase it, yeah, that'll be good.
Yeah, yeah. So I'll try to keep it a little higher. Yep. So yeah, so I'm interested in deep learning and deep reinforcement learning. So I try to keep myself updated with the developments in these fields, and I keep learning, and I have my own approach where I try to learn things by doing them. So I prefer online courses over books and building things myself. Once I learn something, I try to implement it, and I try to explain it to someone else, and that I think just reinforces the learning. Yeah, so basically that is everything I do. What is my definition of AI? Again, not the correct answer, but I would say it's artfully ignorant, because if you look at from an outsider's perspective, AI is something like it tends to be confused with human intelligence, uh, while an insider, I think, would think that we still don't know how the human brain functions, but we have some good approximations. So there are things that we can do with perhaps deep learning that tend to mimic humans very nicely, but it's still ignorant. I mean, to me, I have no doubts about it that AI is nowhere even close to what humans can do. So yeah, that's everything about me. But I would also like to learn about you, like what do you do for at work, outside work, and then of course I have a fun question. So we can go about it in any order, any random order. Please unmute yourself and introduce yourself. We can take some time to do that, and then we will move on to the core, which is what the course is about.
Hi, Farhan. So this
Hi,
is
Srinivas.
Srinivas here.
Hey.
I am a semiconductor compact modular turned ML engineer in recent times. So that's I do for fun as well as profit.
That is very cool.
My
If you do the same thing for fun
I
as
also
well.
do for fun reading and playing music, and then
Like,
reading and playing music is my is my pure fun, no profit intended there. And
awesome.
I mean, unless you have a different definition of profit. And then second, uh, uh, for me, AI is action intended.
Cool,
Okay,
cool. Thanks, Srinivas.
thanks. Bye.
Okay, who wants to go next?
Yeah, hi.
Hope you can hear me. Hi, I'm Divya.
Hi, Divya.
Yeah, I'm part of test team and I'm driving test initiatives which could improve the productivity and efficiency. So that's where I'm driving a team around that, where we do a lot of innovative solutions based on this ML. So at least I have been into this for past 2+ years as of now. So that's what I do. And fun is watching movies. So
Okay,
that's what I do. And AI could be, I could say, like area of interest, maybe. Yeah.
okay, okay. Cool. Thanks, Divya.
Thank you.
Okay, I'm going to go next. This is Sriram. I want to go before all the acronyms get used up. Uh, um, so my name is Sriram. I for a living, I write code. I am relatively new to ML, but I'm thoroughly enjoying it. And in my previous jobs, I've worked on chip design, flow planning, EDA algorithms, optimization, so those kinds of things. And AI for me is approximating intelligence, right? Because I don't think we'll get there anytime soon, but we'll keep getting closer and closer to general intelligence.
Yeah, makes sense. Thank you.
Yeah, thanks.
Okay, who do we have next? I think it's a good time to do a little bit of an icebreaker session because during the course we'll be working with each other. We'll have group projects and everything. So I don't know how many of you know each other personally. And besides that, obviously, I also want at least when I look at a name, I should be able to recollect who does what, and hopefully it lets me connect with everyone.
Somebody from
Yeah,
Chennai can open up, please.
Sure. Hi, Farhan. I'm
Hey,
Naga. Uh,
hello.
I I work as a director in test. Uh, I like to explore things, like to read, like to watch anything new, and then that keeps me motivating. Um I'm addicted to code, so I'm trying to write any code for last year or so because once I get into it, uh, I get deviated from my regular
Yeah.
responsibility. So I'm trying to stay away from code. So this is an attempt that I want to try it once again.
Okay.
To me, AI is like I, don't- I don't know whether it's a true intelligence. In order to extract its intelligence, you need to dump loads and loads of data where we don't have that much of data. It's a challenging one.
Cool. Thank you so much. Okay. I can understand the lateness a little bit. Obviously, when I'm on such a call as a participant, I'm usually not the first one to open up and introduce myself. But please feel free because you are going to be part of this cohort. So like there should be no inhibitions. Everyone gets to know everyone else, and of course we'll keep doing that throughout the classroom as well. So I'm looking for a few more introductions at least, and then we can move on.
So hi, I'm Payal.
Hi,
I
Payal.
work in Shriram's team.
Mhm.
So I'm also mostly associated with chip designing, and I'm also relatively new to ML. But I'm really enjoying the field, and especially because of the things that has been possible by using ML, it makes it even more interesting. There's lots to learn, and yeah, I hope that I'll enjoy learning this course as well.
Yeah, I'm looking forward to that. And what is your what do you think AI stands for?
So AI stands for uh, okay, sorry, I missed the initial set of discussions. I joined late, but yeah, let me think. So AI stands for. I think it's for now, I think it's mostly to use some sort of data to find some sort of structure in it, and using that to learn and improve what is already possible to achieve. So I don't think it's completely intelligence in that way, but it is mostly to learn from data in some way.
No, cool, cool, cool. I think that's right. Uh, we were just looking for incorrect definitions, fun definitions, but it's fine. Uh, yeah, anyone wants to go next?
Hey,
I can go next. Okay, good.
hey, sorry. Yeah. Hey, Sri Chandra here.
Oh,
Yeah,
good.
uh, I've been working in an applied machine learning team here at Qualcomm since my graduation. So for the last 3 years. Yeah, I play badminton and I cycle. I do cycling for fun. If I don't find any friends, I go cycling. Else I play badminton. Then yeah, AI. I think I'll give slightly offbeat answer. Right, AI for me is all in for someone who plays poker because I used to do that while at college.
Yeah.
Yeah.
I was actually thinking about whether we should have any examples, any card playing games, because when you look at books, there are lots of examples of card games when you're doing reinforcement learning. But then I myself don't play cards a lot, so sort of decided against it.
Okay.
So thank you so much.
Yeah. Thanks.
Okay. Yeah, I can go next. Hi, this is Shantanu. So, yeah, I'm also from Sriram, Payal and Sichanda stream, right? We are in this machine learning team, JMRD team, right? Working on, optimizing the physical design flow process using ML, right? Regarding fun stuff, if you just, talk about this paradigm itself, for fun, I'm trying to do some quantum computing and quantum machine learning in my spare time, right?
Yes.
Yeah,
Oh,
and
that's pretty cool.
yeah, okay, and yeah, for AI, if you ask me the definition of AI, right? So AI, the definition of AI, shifts every generation, like right, every so few years, the definition of AI changes
Right.
because what I feel like, what is AI today, right? Once it has been solved, those problems that will solved through AI, right? They would no longer be categorized as AI, like whichever is remaining to be solved as AI, right? So, I mean, previously, like playing chess was considered AI, right? Right now, it's not considered as AI because systems can beat the good players easily these days, right?
Right.
So I'm just waiting for that AI singularity. Let's say, like if that stage any time comes soon. Yeah. Yeah.
No, thank you. And I can't agree more because we can't really be very specific about what we want when we say we want AI. There were things that were considered AI 2 decades back, and they are now considered normal software programs. So I think that
Yeah.
trend is going to continue for some time.
Sure. Sure.
Okay, thanks again. Okay, anyone wants to go next?
Yeah, hi. I'm Arvind. So I work in this test team where we develop the ML solutions for bringing out tools. So for fun, I always hang out with my friends and go on a trip or something. That's what I do for fun. And to me, AI is something. It has become something like awfully inexplainable kind of stuff. So yeah,
Yeah,
so that's pretty much it. Thank you.
thanks, thanks. I'm sorry I didn't remember your name.
It's Arvind.
Arvind, thank you so much.
Yeah, thank you.
Okay, anyone would like to introduce themselves?
Hey, yeah, I'll go. Hi, I'm Srishti. I also work with Sriram and Sri Chandra, Shantanu, and Payal. So I'm also a part of their team. Um, for fun, I like to read, and the last year has not been a good time for having fun. So that's mostly what I do. And AI, as Shantanu said, that it has been changing a lot since the last 10 years. But what I would say, one constant across it is that it has always been amazingly inventive. So that's what
Yeah,
AI means to me. Yeah,
no, that's
thanks.
right. I think that is what brings us together, because there are certain things that have been possible, let's say in the last 5 years, which were never thought possible before that.
Right.
Cool. Thank you so much.
Thanks.
Hi, my name is Sudhir. I work in test productivity improvement tools using ML.
Mhm.
So that's what I do for living. For fun, I play badminton, or I'll do some physical work for fun. And according to me, at AI, I had totally opposite perspective, because it's not actual intelligence. So I don't know when it can beat this actual intelligence or not. So that's
Yeah, we
yeah,
sort of touch upon that in the course. We won't
yeah,
like go into the philosophical aspects, but yeah, we will.
yeah, that's it.
Thanks, Udit. Okay, is there anyone remaining? Cool. No worries. I think we can move on. We will get a chance to introduce ourselves in the classroom as well. It's a small cohort, and we will be working on lots of live programming uh, during the classroom, which the sessions are basically about. So you will get to interact with everyone else. So let me quickly move on to the agenda. It's going to be roughly 15-20 minutes. So I want to give you an overview of what the course is about, what are we going to cover in terms of concepts, and how are we going to do that. That's equally important. Then what the target learners are. I'm sure you have already like signed up for the course, so you understand that this is something relevant and it will be valuable for you. You'll be able to apply things at work. But I want to talk a little bit about what exactly are the outcomes, learning outcomes of the course, and then of course the logistics of the course. So in terms of the course overview, we have three different modules. What we're getting started with from tomorrow is the first one, which is the introduction to reinforcement learning, which is a 4-week module, right? So this is what we will get started with. I understand that there is a mix of learners. Some of you already have done different courses or trainings on reinforcement learning, but we will still try to keep it very engaging and exciting, and I'll talk about that in a moment. But this is what we will do for the next 4 weeks, after which we will sort of dive into deep reinforcement learning. So by the end of the first 4 week, you have a good idea of what reinforcement learning is about, and more importantly, you know how to code different problems, how to solve things programmatically. uh, and after that, you start working on the more recent development, which is combining deep learning with reinforcement learning. And there are two broad sort of areas. One is what they call value based methods. So we'll explore that in the next 4 weeks, and after that we will explore policy based methods, and we will come to the exact definitions when we reach there. But this is how the next 12 weeks are going to look like. Now, what is different about this course is, because there are lots of online courses, free courses, paid courses, uh, uh, things on YouTube and elsewhere, is the methodology. So typically when you're getting started with any course and reinforcement learning or AI, so you typically go through a lot of equations, theory, derivations, proof, whatever, in the hope that you understand the basics, and then there is some project work or some exercises or whatever. But in this course, we are going to take a diametrically opposite approach. So what is going to happen is we will start with a problem, right? And I'll talk about the problems in a little while, but we start with a problem, then we try to model that problem. And when we are trying to do that, we might not have an in-depth understanding of all the mathematics or all the theory in general that goes behind it, but we will try to formulate it in terms of things we already know. For example, we will try to work out a solution to a specific problem using dynamic programming, and then slowly we will make the problem more complex, and then we will see where dynamic programming sort of stops to help you, and then where you need to apply other methods which are variants of, you can say, dynamic programming, and how reinforcement learning can work you. But this is the general approach: to start with a problem, then build a model, maybe do some sort of a simulation, then write some code to solve it. Sometimes we'll also deliberately fail to try to understand why a certain thing doesn't work. But once you do step one and two, then step three comes in. That is where you understand the terminology that is generally used in the domain, and the equations, and a little bit of proof or derivations and things. This is going to be very fast paced. So every session, there are 2 sessions in a week. I'll explain how the course is structured, but there are 2 sessions, and in every session we spend a good deal of time just writing code, right? So building something, simulating something, solving something, and that is what we are doing most of the time. So it's not a session where I'm going to do a lengthy lecture and do a presentation, and nothing of that sort happens. If there are presentations, that roughly takes up 25-30% of the session, and then we are back to coding something. And the idea is to keep it engaging and, more importantly, hands on, because when you're building things, when you are you know trying to simulate something, trying to solve something using code, you get a very in-depth understanding of the problem and of the solution, and how people came to uh, you know uh, came to know about the solution, and how did they chance about the solution, how did they discover the solution. So you start sort of try to get into their shoes. Okay, this was the problem, this could have been the approach, and this is how it has evolved over time. So that is going to be that is our methodology. And of course the focus is on building things, and I hope this remains like engaging for everyone. uh, and if I talk about the specifics of the projects that we are going to do, so the first module is an introduction. So in the introduction part, what we want to do is we really want to understand what sort of problems you can solve with reinforcement learning. Now, some of you, because you're already working in that domain, you have a good idea, but we still sort of want to get started from the basics so that everyone is on the same page. So we'll think about what sort of problems we can solve, when we are doing that, we will actually create a few problems. So there's something there is an environment that we are going to build. We will call it foosball. So it's a small toy problem of our own, and we will use that throughout the first course to understand how you can use reinforcement learning, where you can use reinforcement learning, and then also understand how the different frameworks out there, for example, OpenAI Gym and Unity ML and other frameworks, why do they follow a certain pattern? Why do they offer a certain type of interface or API? So we will do that by building our own environment and solving a simple problem. The good thing about this environment will be that this environment could be evolved into the future. So when we are doing course 3 or course 2 or module 2 or module 3, then we can add more complexity to our environment. We can make it more realistic. Uh, and the other good thing is that this is a text-based environment, so we will be able to do a lot of experimentation in the browser, in Google Colab itself. So we won't have any dependency, because the only dependency is going to be, I think, NumPy. But then in part 2, we will pick up problems from these standard frameworks. So there's something called slime volleyball. So we'll work on 2 different variants of that. It's a small video game where you have to control an agent. There are 2 variants. One where you have to learn from pixel data, another one where you have access to the ground truth, sort of. So we will solve those problems. And in the third part, it will get even more realistic. So you are solving some sort of an autonomous system, training it to solve a problem. Uh, the one that we will work on in the classroom will be a, a 2D driving environment, and then there will be a project where you have to control a robotic arm. That is sort of the take-home project that you have to work on. So if you look here in the right column, so there is a C and a P. C stands for the classroom project. This is what we will be working on or coding up during our sessions. And P is the take-home project, which you have to do on your own. Uh, and I will talk a little bit more about that in the next few slides. But let's talk about the target learners first. So, who is the course intended for? So, anyone basically who wants to learn about reinforcement-based AI learning, like what sort of problems you can solve with reinforcement learning, and how far really you can go, what is feasible right now, what is not. In terms of experience, you should be familiar with Python. I'm not expecting anyone to be an expert, but just be able to read Python code, write Python code, and whenever necessary, be able to debug it. That is the expectation, and of course, some experience with deep learning, so building neural networks and using any framework. But we are going to use TensorFlow, but even if you are familiar with PyTorch or and the framework, that is also fine. They are look they all look and feel pretty similar, so that won't be an issue. But in terms of prerequisites, this is all I'm hoping for. uh, what sort of is going to be the key takeaways? So of course we will explore reinforcement learning algorithms, starting with the basic classical algorithms that you get introduced to in every book. But along the way we will also build, like I said, we'll also build our own version of environments, and we will build the algorithms from the ground up, so we have a really good understanding of the basics. We will use the OpenAI gym environment for some of the early work, so we will get to know its APIs and the different environments that it has to offer, and the different baselines, the work that others have done. We will also be working on different types of data. So we'll start simple with a few input variables, with a few variables that you have to learn to control. Then we'll move on to more complex worlds where you have to learn from pixel data. So we'll do that. We will also pitch agents against each other. So set up some sort of competition or a game, and that lets agents learn by playing against each other. uh, and towards the end, like you saw, we will be training some complex systems like a robotic arm that is fairly complex, so being able to uh, train a robotic arm that can pick up objects and move them in an unconstrained way, where you're not programming it, where you're not telling the actuators to move a certain distance, but but the algorithm is able to learn it from interaction with an environment. uh, we will look at a few other environments. We won't work with them a lot because we have some constraints. We can't assume that everyone will have access to a GPU or an environment where they can set up these frameworks, but we will look at PyBullet and Gazebo and a few other environments that let you simulate real world models and then interact with those models. So that sort of is everything about the takeaways. Uh, so how is the course going to look like? I already sort of showed that to you. So there are 4-week modules. The one we are going to start from tomorrow, that is the introduction to reinforcement learning. Then we will have another one in May perhaps, about value-based methods, and then after that you have policy-based methods. These are the courses. How are we going to structure our week? So we will have classroom sessions. Each classroom session will be 2 hour long. Like I said, most of it will be spent programming up things. So every Thursday and Friday from 3:30 to 5:30, we will have classroom sessions. The Zoom links have already been circulated. They are also linked here. We also need to have an office hour session. The timings we'll figure out once everyone is on Slack. So I'll do a poll and try to understand what are the timings that suit everyone else. I do want to mention that we have another cohort going on in the Pacific time zone. So the way we do it there is that Thursdays and Fridays are meant for classroom sessions, and then on Mondays you have office hours. So between Monday, uh, whenever there is some homework or reading assignment or something like that, you get some time between Monday and Thursday to work on it. But we can figure out our own timings and days. Okay. In terms of format, already mentioned 2 hour long sessions every Thursday and Friday, uh, mostly coding based. It will, will use a feature that is present in Zoom that lets you split into small groups. We call it breakout sessions. So we do breakout sessions, very frequently. So during a session, I'll explain something, and then there will be a problem. There will be some starter code, but the rest of the code has to be written by you, and then you split up into small groups, and then you work with each other to come up with a solution. Now in the beginning, like in the first module, there will be some starter code to be started with, but as we progress, the starter code will get smaller and smaller, and the focus will be to just figure out the entire solution by yourself. The office hour I didn't mention, but it is 60 minutes long. The intention is that anything we discussed over the previous Thursday or Friday, so we get a chance to see solutions. If there was anything that was pending on Friday, so we can look at solutions. We can have question and answers, discussions. Uh, the format that we are following, so it becomes a little difficult if you miss a session and then you want to catch up, so you don't get the same level of interactivity. Having said that, if there are, if you're unable, then it's fine, everything is being recorded. We will sometimes it takes up to a day for the recording to get available, but then I typically share it in the Slack workspace. So the recordings will be there. All the code is being committed to GitHub. So the starter code and then the solutions, they are also going to be, sorry, get pushed to GitHub. And so it is nothing to worry about if you happen to occasionally miss a session. Uh, the focus is not to have a lot of homework. So whenever we have homework, it will either be some sort of reading assignment from a chapter from a book or a research paper, and more often the homework will be some sort of an implementation. So if there's a problem, we implement 60%, 80% of it in the classroom, and the remaining 20% is the homework, right? And as I mentioned, there is a project every month in every module. So somewhere during week 2 or week 3, you have to get started with that project on your own time, and then you have to submit it 1 week after the course ends. So if it's a 4 weeks long 4 weeks long course or module, so by the end of the fifth week is the hard deadline for your submission. So once we launch the project, once we are in week 2 or week 3, depending on which course it is, we introduce you to the project. So after that, every week we will have a soft deadline where we can discuss things. If there is any issue, any problem, you are stuck anywhere, and then 1 week after the course gets end, you have to positively submit your solution. The classroom projects, because the solutions will be available on GitHub, they are self-graded. You just have to make sure that you understand every bit of the project work, because that is where the learning is happening. Uh, but for the take-home projects, they will be evaluated by me. It will take some time, but they will be evaluated, and I'll share the feedback, and we can have discussions after, on Slack, and the feedback will be given to every submission. Uh, in terms of the tools we are going to use, we want to keep it really simple. So GitHub is one thing we are going to need. Even if you don't have access to GitHub on the laptop or on the system that you're using, it's fine, because most of the time we will be working with Google Colab. So the way it works is there is starter code. I give you a link to the starter code, the repository, and you can sync it to your Google Colab notebook in the cloud. So even if GitHub access is not available to you, it shouldn't be an issue. Now, if you want to work offline on your own system, that is also fine. There is no restriction as such. Uh, our setup is very minimal in the beginning, so there isn't a lot of packages to install. I'll share an environment file that you can install and work offline as well. But I would highly recommend, because then everyone has the same experience, and uh, it's just very easy. It's one click and you're set up with everything, and you can work in Google Colab. So that's entirely everyone's call, but I would recommend working in Google Colab. And then of course Colab will also provide us GPUs whenever we need them. For example, in course 2, course 1 does not require any GPU, but when we do some more specific work where we want uh, more horsepower, so to say, so that will be in course 3. And we have had some discussions about AWS access for everyone. So we'll figure out a way to give everyone AWS access, so you can quickly have a quicker turnaround and train more and more frequently, train your models. Uh, yep. For communication, I'm going to set up a Slack channel. There is already a workspace for the other cohort, so we will be using the same workspace. But within the workspace, we are going to have our own dedicated channel for this cohort. So I'll set that up. I'll set everyone an invite once I have your emails and names. And then you can also send email to me. So emails are generally slower, Slack is faster. And Slack is also better in other ways. We can share code, and of course all the recordings, books, readings, any references, they'll all be periodically shared on Slack. So we will have a running record, a history of everything that is being shared and how the course is progressing. And any discussions we have, that will also be there for anyone else to look up and find things. um, yep. I think that is everything about the course that I wanted to cover. But if there are questions about anything, I'm happy to answer. And once we have Slack set up, then you can also ask me questions there. Yeah, please, feel free. If you have any questions about what is being covered in the course, anything at all, about outcomes or anything, so please feel free to ask now. Or you can post in the chat as well. And this one thing that I sort of skipped over, which was about the projects. So we have projects, we have projects in mind that we want to do. But when we get close to the project, and if we feel that, some of you feel that the project is maybe too easy, perhaps P1 may be a bit too easy, if you are already familiar with reinforcement learning, then you will have the flexibility to work on an alternative project which is more interesting, more meaningful.
So we will be using the latest TensorFlow version, right?
Yeah,
2.4.1.
right. Yeah.
Okay.
So we will use TensorFlow 2.0. Okay, there's a question about resources for Python. So I will share. I'll share a few resources if you want to get started with Python, because Python is really very similar in terms of syntax. It's very similar to C, or even C++ or Java. So I think it won't take more than a couple of days,
Okay,
but
great. That's
I'll
good to
show
hear.
those.
Thanks.
Sure.
Yeah.
Yeah, in terms of mathematics, we just need a little bit of understanding of, I won't say a little bit of, matrix algebra, linear algebra, and calculus. That is for the deep learning part of it. For deep reinforcement learning, all you need is probability. So good understanding of probability, and if anyone feels that you need some sort of a reference book, I can pull out something. Yeah, so in the beginning, so the question is how much of non-deep reinforcement learning is covered in the course. So when in course one, basically we are dedicated to the basics. So the different algorithms like Q learning, SARSA, different variants of it. Uh, that is what we are going to cover in course one. But course two and course three are mostly deep reinforcement learning. Okay, so if there aren't questions, I think we can like give everyone back their 10 minutes or so. And like I said, I'll be available on Slack. You should get the invites as soon as I have your email and names. So then we'll have our own Slack workspace and channel, and you can ask questions there.
Great. Thanks, Varun.
Okay, thank you all once again.
Right. Bye.
Thanks. Bye bye.